Tonight, we're going to find out what the furthest thing we can see is through this telescope. Good luck, telescope. From one of the darkest spots on the planet, Jupiter is 600 million miles away. I'm going to show you live views. We've just been photobombed of more and more distant targets, and we're going to see how far we can get. The light set off before the Normans invaded England, as modern humans just evolved. Before the dinosaurs even existed, can we break the billion light year barrier? Ooh yeah. How close to the beginning of time and space? How close to the Big Bang can we actually get? The music for this Astrobiscuit mission is brought to you by His Majesty King Riktenstein. Details of all the astro gear used in this video on my website, link below. You can support the channel by subscribing, becoming a patron, or buying one of these extremely fancy limited edition space prints. I am in one of the darkest places on Earth, the island of Palma, and more particularly, I'm at the Athos Observatory, because in the shadow of this observatory telescope here is a star camp, which is a bit like Butlins for nerds. Say hello, fellow nerds. We come here because there's blooming great skies. Not only is it dark, but also we're sitting above all the low clouds on the leeward side of a massive volcano which blocks the higher clouds, leaving this place with clear skies for 296 days a year. Wow. To make use of this nerd paradise,
these are the bigger scopes.
The owner, Kai, has a huge amount of nerd gear, and he's let me take my pick. To successfully journey to the edge of the universe, we're going to need to point the right way. This is the one I want. This is one of the best mounts on the market. 16,000 euros.
Yeah.
And you're going to let me play with it?
I was a little bit scared. yes, you can. It's okay.
Don't worry, Kai. Normally, I just break telescopes. Luckily for Kai, I don't want to use this very precious and specially modified C14, even though it has the biggest aperture and is the most zoomed in. And that's because when you're looking at very, very distant objects, being zoomed in isn't the critical factor. Truth is, these objects are so faint, it's hard to see them in the first place. So I'd rather use this relatively modest, although it is still $3 grand, 12-inch fat Newtonian, which specialises in guessing the faint stuff. And thanks to super sensitive modern cameras, this setup is better than any observatory that existed on Earth when I was a kid. Pretty fancy, huh? Although there is one thing that is distinctly not fancy. It's my 20 quid homemade Peltier cooler and fan. You may laugh, right? But it'll reduce the dark current by half. So for 20 quid, yeah, I'm going to do that, right? Tonight, starting close to the Earth, we are going to take giant steps, each 1,000 times further than the last, out into the void. Now there is an upper limit to this, folks. The professional nerds say the universe is 13.7 billion years old, which means the universe's first light began its journey 13.7 billion years ago. And as light travels 1 light year every year, then in just 6 of our massive steps time, we'll be looking at objects that are billions of light years away, and from a time gobsmackingly close to the moment of creation. I have to be honest, I am hoping we can get close. Okay folks, the sun has nearly set. It's time to begin our quest. Beginning with that little one there. The moon is 384,000 miles away, and it takes 1.3 seconds for its light to reach us. Now, one of the reasons I wanted to start with the moon is that there is our field of view. Now, that field of view is going to stay with us all night as we go further and further into the universe. Okay, now we need to find an object 1,000 times further away than the moon. And that's actually pretty easy. Jupiter is 600 million miles away. It takes 40 minutes for the light to reach us. Obviously, you don't need a big telescope to see it, but this is what it looks like through a telescope. Even though tens of thousands of moons would fit inside Jupiter, it's so far away that through our telescope it looks quite small. And this highlights a problem, because we're going 1,000 times further away than Jupiter, to a mysterious cloud which cocoons our entire solar system. And here, in the space between the stars, humanity is yet to find an object that is big enough to see. Undeterred, the professional nerds believe it's teeming with a cloud of 100 billion New York City-sized snowballs. You can't see the blooming comets, not even NASA can see them. They can only see them when they come closer to our solar system, and there is one that's come closer, so we're going to have a look at it now, even though it's a little bit of a cheat because it's nearer to us than Jupiter is actually, but it came from a place that was light years away. Some comets accelerate towards the sun from a whopping 2 light years away. And despite being Tidge, by the time they get here, they're going so fast, a direct hit would wipe out every single last one of us. Here we go. Now we're heading 1,000 times further away than the comet cloud, to the Orion Spur, which is kind of the mini spiral arm that the sun is part of. Our spiral arm may not be the biggest, but it makes up for it with some whopping star factories. My favourite is the Orion Nebula because it's just so blooming awesomely massive. To give you a sense of scale, this little dot here is about as big as our entire solar system. And up here, next to the left-hand star of Orion's belt, is the Flame Nebula, whose burning heart is obscured by dark dust lanes. And there's more. Oh, did you see it? We've just been photobombed. I believe that is the spent fuel cell from an old Russian rocket. And it's just got across our screen, right? This is live viewing, folks, so anything can happen. But let's ignore it, because up here is another really famous one. If I turn the brightness up, we'll see it. It's the Horsehead. Now, the light reaching this telescope set off before the Normans invaded England. But that is nothing compared to what we're going to look at next, because we're going outside our galaxy for the first time, folks. As we leave the Milky Way, we pass mysterious clusters of very ancient stars. The light from this globular cluster set off as modern humans just evolved. They're 100,000 light years away, but this step takes us to more than 1 million. Can we break the million? Oh yes, we can. In fact, it's surprisingly easy. I mean, it would be if we weren't pointing straight at this tree. Ugh. In all honesty, you don't need a big telescope like this to break the 1 million light year barrier. In fact, I'm going to do it with this camera. Heads up, this object is so big, it wouldn't have fitted inside our telescope's field of view anyway. There she is, Andromeda. With the naked eye, the Andromeda galaxy looks like a smudged out star. And that smudge is 6 times wider than the moon, even though it's 2.5 million light years away. Galaxies are so mind-numbingly big that to show you one in the big telescope, I'm actually going to have to find one that is further away. Now, you do need a telescope to see this, and it is a beautiful sight. So, here we go. This unexpected mini-step is taking us 10 times further into the void. Oh, it's very low. Can we see it? Yes. The Whirlpool Galaxy is basically 2 galaxies in collision, and the light from this collision has been travelling across empty space to our telescope for the last 30 million years. And if I stack all the frames from this video, this is what it looks like. Oh, I need to get some more warm clothes on. And things are getting more serious. We're getting close to the edge of the universe, but because of our unexpected mini-step, if we did another big step, we'd actually overshoot. So from now on, we're going to do mini steps, which are 10 times rather than 1,000 times further than the last. We are about to attempt to see something 300 million light years away. And that is going to be tough. To see an object at this jaw-dropping distance, with our moon-sized field of view, we'll need to find something much bigger than a galaxy.
There she is.
And the only thing bigger than a galaxy is a cluster of galaxies.
That's 3,000 galaxies in a very tight, dense group.
The galaxies are drawn like moss to a flame to the two supergiant elliptical galaxies at the cluster's centre.
The light that we're seeing now coming through this telescope set off before the dinosaurs even existed. And if you look at it, you might notice something a bit weird. All the galaxies are kind of orangey red. And part of the reason for that might be to do with dark matter, but another reason is because over 300 million years, the light from those galaxies has been travelling through the universe. This is the light travelling through the universe, right? And as it does it, the universe starts to expand. And as the universe expands, the wavelengths of the light get longer and longer, which means what started off as blue light gets turned redder as the universe expands. We're just beginning to see this now. Weird is beginning to happen, folks, but it's gonna get weirder. Because we are now going to attempt to break the billion light year barrier. Ooh, yeah.
A billion light years is so massivo, even galaxy clusters will be hard to spot with this telescope.
Luckily for astronomers, a billion years ago, the universe didn't look how it did now.
Back then, well, bacteria ruled the roost on Earth. The heavens were dominated by quasars. For a long time, quasars were mistaken for stars in our own galaxy. But actually, they're more like incredibly, incredibly distant stars that are the size of a galaxy. These are the brightest objects in the universe, and the only things powerful enough to power them are, you've guessed it, supermassive black holes.
They drag the dust and matter and gas in towards the black hole, and you know, like when you pull a plug hole, water doesn't go, it kind of goes, it spins round before it goes in. Well, that spinning round creates unbelievably intense electromagnetic forces, which then send radiation spewing out across the universe.
I'm confident we'll bag this quasar, because it's 1,000 times brighter than the 40 billion stars that make up our Milky Way.
Art. The best shot of breaking the billion light year barrier is on the other side of that volcano there.
Uh-oh. We're going to have to jump to the next quasar on my list, which is 8 billion light years away.
I'm going to make a little modification to the camera, because if we're looking at something that's 8 billion years old, the redshift is enormous.
So to give us the best chance, I'm removing the camera's infrared blocking filter.
And because we're going to go for something 8 billion light years away, I'm also going to get my fan and Peltier cooler working, because we are going to need as much help as we can get to see this one. Here we go.
The light we're about to capture has been travelling undisturbed through space for more than half the age of the universe.
It's getting very serious now, folks.
Alrighty, where are you? That's a galaxy. There's another galaxy. We're not looking for that. Most quasars kind of look like blurry stars, although this one is a little bit different.
Now, there's something weird about these two splodges that look pretty much like blurry stars. If you analyse the wavelengths, you realise that they're exactly the same. In fact, it's the same object that is doubled up. Something has turned what looks like one quasar that's 8 billion light years away into two.
This is something Einstein predicted. but he never got to see gravitational lensing in action.
Somewhere in between us and the quasar is something really heavy, like a supermassive black hole.
The really heavy thing bends the light from the quasar that passes above it and the light from the quasar that passes below it towards the Earth, creating a double image.
And I'm hoping for the pièce de résistance to be able to use gravitational lensing to take us even further back. Now, bearing in mind the universe is only 13.7 billion years old, and we are already at 8 billion light years. So how close to the beginning of time and space, how close to the Big Bang can we actually get?
It's 4 a.m. in the morning, folks,
I think it's probably a couple of hours before the sun comes.
and I'm worried we might have reached our telescope's limit.
Now, in all honesty, I cannot see the thing that I'm looking for.
Our gravitational lens lies 4.5 billion light years away, and the things we're trying to bag lay several billion light years behind that. This is what it looks like through the Hubble Space Telescope.
It's called the Cheshire Cat group of galaxies because there are two eyes.
The two eyes belong to the gravitational lens. The smile and the outline of a face belong to galaxies from the very dawn of our universe.
I think I can see the two eyes.
Thing is, the cat's eyes are supersonically faint, and I definitely can't see the smile. So is this the end of our journey? Well, not necessarily.
Can't see the thing that is getting gravitationally lensed, so I'm going to take a whole bunch of 60-second exposures, and in the morning we'll see if we actually managed to catch something from the very beginning of the universe or not. Good luck, telescope.
I am hoping, folks, that if the early morning clouds don't roll in, we'll gather enough 12 billion year old photons to be able to see the cat's smile.
Morning, folks. Oh, that was a long night. So, the scope is now got its cover on. My computer is now processing the data we got last night. Guess what? I didn't get as much data as I wanted.
30 minutes after I went to bed, Windows 11 shut the laptop down to install an update. And that has significantly reduced our chances of bagging the smile.
There it is, very blue. Let's neutralize the background. Let's bring up the brightness a lot. So it's going to be very noisy. But you can just about see it.
Well, I think I can see it anyway. It's like a ring going around the cluster.
I mean, I'm pixel peeping here.
The faint ring could just be random noise. Luckily, I can prove a 12-inch Newtonian can get the Cheshire Cat smile, because Morton LaCour did it with his. Well done, sir. It just took 30 hours, so if we had a bit more time, I think we wouldn't be umming and ahhing about whether we'd got it. We'd have got it. Which means this telescope can catch photons that have been travelling for 12 billion years. And whilst they were travelling, the universe expanded, which means incredibly, the object itself is now even more than 12 billion light years away.
Yeah, how far can we see through that telescope?
Quite a long way, I'd say.
We can see quite a long way.
Thanks, Kai, for letting me stay at Nerd Paradise. You can come here too. Just get in touch with Kai on his Facebook page, link below, and you'll be treated to some of the best night skies on the planet. And if you can't make it, why not do the next best thing? And buy the nerd in your life a picture that I took here.
We have two limited edition prints. Here's one of them. It's the Horsehead Nebula and Friends, and I know this sounds horribly big-headed, but I don't think even NASA has done a better shot of this.
These are absolute top quality art prints. Unfortunately, the big size of the nebula around Orion's belt has sold out, but the other sizes are still available.
That is how big it would actually look if I could see it with my eyes in the night sky. Still blows me away.
Another great Christmas Prezi idea, especially now that the planets are out, is a telescope. And this nerd maker only costs about £100.
Wow.
Find out more by clicking on my Best Telescopes for Christmas 2024 blog, link below. And to help you cope with the Christmas stress, Riktenstein has composed a chill-out album which will transport you from your armchair deep into space. You can listen to it now on Spotify, YouTube Music and Apple Music. Give it a go, I'll link below. If you enjoyed this video, then you and I, all of us actually, need to raise our glass to my patrons. Cheers, patrons. Without your support, making these videos would absolutely not be possible. I do not have enough views, and some patrons have been with me for years, so this one's for you. Thank you. Hope it's been worth it. Patrons can message me anytime, get early access to my videos and products that I'm selling, and prints and access to special channels on the Discord server. Patrons pay for the videos, the prints pay for mad new schemes like this. Woo. A mega nerdy mega shout out to the mods and wonderful people on the Astrobiscuit Discord server. You guys are doing such a good job. Thank you. And thank you for watching all the way to the end. Don't forget to subscribe, buy a print, and then buy a telescope from one of my affiliate links. Anyway, have a happy Christmas, and yeah, don't nerd out too much. Bye.